Understanding some key terms is very helpful for us to use Kafka Streams and build a real-time stream data processing application. So in this section, I will introduce some key terms in Kafka Streams. Let's go through them together. DFP. Kafka Streams leverage a programming paradigm called data flow programming. In short, is DFP, which is a data-centric method for representing programs at the zeros or inputs, outputs, and processing stage. DAG. The stream processing logic in a Kafka Streams application is structured as a directed acyclic graph. In short, is DAG. Source processor. Sources are where information flow into the Kafka Streams application. In other words, the source processor will consume the data from Kafka source topic and flow into Kafka Streams application. Stream processor. These processors are responsible for applying data processing, transforming logic of the input stream. Sync processor. Syncs are well enriched, transformed, filtered, or other words, processed records are read back to Kafka. Topology, a collection of processors and the stream forms a processor topology. As you can see this figure showing, the source processor will consume the data from Kafka source topic and flow into our Kafka Streams application, and this is the streams. Since several stream processors transform the source record and finally to get the result, those results will be synced to the target topic or produced target topic by sync processor. Subtopologies. The Kafka Streams will divide our topology into smaller subtopologies to parallelism the work even further. This divisions of work is possible since operations one input stream can be executed independently of operations on another input. Stream task. A task is the smallest unit of workers that can be performed in parallel in a Kafka Streams application. For example, if your topology reads from one source topic that contains 16 partitions, then the Kafka Streams will create 16 tasks, each of which is the installation its owner copy of the underlying process topology. Once the Kafka Streams has created all of the tasks, it will assign the source partition to be read from each task. And the streams thread. The threads, on the other hand, are what actually execute the task. In Kafka Streams, the stream threads are designed to be allostate and thread safe. So we can suppose the stream task is similar to the Java runable or callable interface. It's just only used for write the data processing logic source code. And the streams thread, it is very similar to the Java thread used for execute the stream task. As you can see this figure showing. Suppose our topology will consume the source topic is 2, and based on the source topic partitions number, we will create the 4 tasks, and each task will be consumed the 2 partition from the different source topic, And this is the subtopologies, right? And this is the task. And also the task will not ready to execute. It must depend on the thread. The thread will execute the task. Absolutely, in this figure, we can find all of those tasks be executed by a single thread, right? In next lectures, I will introduce the Kafka Stream parallel model. All right, see you next lecture.